So here I am after a long day of having fun. Um, it's said that if you do something that you love, you never work a day in your life. And I think that might be true. I think that is a true statement. So, did I ever tell you I love chemistry? One of the things about platinum is it has a really high melting point, and a tremendous amount of enthalpy. Enthalpy is the resistance to change. We used platinum as a really stable metal for our meter rods and the little weights that we use for grams and kilos and that sort of stuff. We made them out of platinum because when you make it out of platinum, that's how it stays. See how shiny this is? That's because it's not silver; it's platinum. Um, and the platinum is resistant to tarnishing and that sort of thing because it's platinum. It's pretty stable, except when it's exposed to nuclear fusion. In a fusion event, it starts absorbing neutrons and alpha particles because the metal is so very, 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 very dense. It's denser actually than plutonium, and they use plutonium not because it's a great fissile material like uranium. It's not. It's just beta emissions, but what it is really dense, like lead. Denser than lead, like gold. 19 has a specific gravity of 19. That's its weight to volume ratio. Okay, so we've got a little disc here, kind of. It's not all together, as you can see, but what, 3 centimeters, right? 3 centimeters by 2 centimeters or 2.5, and some of this stuff is silver, necessarily so because I melted some silver into it to make it start melting, and it still doesn't melt very well. Even with a plasma torch, man. Um, Even with the plasma torch, it doesn't melt very well. But I'm learning as I go, and so the next step, I think, is to break out the induction furnace that uses magnetism to melt metals. So, and I can put my little crucible in there, and it'll just heat the whole darn thing up in a couple of minutes. And then I can pour it out and make little bars out of it and stuff. And, rings and other stuff. Whatever I want, right? It's, so I put one of those bars of silver in, and that's, there's got to be, but a lot of it, goes away because I had the air pressure on really strong, and I'd go, and it melts on the bottom of the crucible, and take off for parts unknown on the passing air because it just turns into like little flakes of stuff. So anyway, what I'm doing is trying to melt it and then stir in the AUPT, and that's what we have here is this kind of mixture that didn't quite melt all the way. But this is AUPT here. It is AUPT. And other stuff. But you can see the gold, platinum, gold, platinum. And it's heavy, very heavy. Wow, huh? Far out, man. We're we're living and learning as usual. You know, if it was easy, somebody else would have done it a long time ago. I think that actually somebody did do it a long time ago, but they didn't tell us about it. And they told the Butcher Cortez it was a city of gold. So, if you're wondering what platinum looks like, that's what platinum looks like. Isn't that cool, huh? I mean, that's maybe platinum mixed with silver, but silver tarnishes, yeah. Right. So when you melt it and it recombines the melt creates silver oxides and sulfides, and they collect on the surface. And generally, we we put it in what we call a pickle to remove the fire scale. But I did that the other day to some really pretty stuff that I had, and it all turned fucking black now. And so I'm not gonna do that again. I'm not gonna pickle this. It's just fine the way it is. It works pretty good in acid. Vinegar is kind of a mild acid, and it'll take off a lot of fire scale on this stuff because this stuff reacts really heavily with the alkali and alkaline metals that we use in pickle. And that's how they get the fire scale off. Boy, this is nice and heavy. I'm very pleased here. Very pleased. That's platinum. So, and it's all mixed together, and this is not actually like a problem so much as a feature, if you know what I mean. Because it's absolutely usable the way it is. There's nothing wrong with it, man. I've been whacking on it, and it bends and does like metals are supposed to do. Um, so I'm happy. That's a nice day's work right there. About 2 ounces of AUPT. A lot of work, but I learned a lot too. So, you pay for your education as you go along this way. So, and the thing about having AUPT show up when I started with silver in a metallic form is one of those things where I say, when you can make accurate predictions in the real world, you got good science. So we're working on some good science here for everybody, because we need platinum and AUPT to do high-tech society type things, man. This is what you use when you're going to space, when you fly, when you build computers that work in 3 dimensions instead of just 1. Passes magnetism with no resistance, or very little resistance. It's got some resistance, but not much. So it's not magnetic at all, not even a little bit. But, oops. Okay, let's see if we can, and whoa, it's almost sticking to the bottom, see that? And these are just little tiny magnets. Anyway, sticks this time. Alright, anyway, passes magnetism. Even these little weak magnets, all the way through that whole thick piece of metal. And this is the most dense metal. Just about in large quantities, certainly, and I mean, I worked for a few minutes today, basically, and this came off of a dirt road yesterday. My wife picked it up off of the side of the road. You know, and silver from China, but the silver kind of vaporizes at plasma torch temperatures. It doesn't stick around much, but the platinum does, and the AUPT does. And so what we're gonna do is melt it really good with my induction furnace. And then I think we'll have some homogeneous looking AUPT. Gold, platinum, gold, platinum. And that's how it goes. Look at that, gold, platinum, gold, platinum. and they're big, you know, big. And when you get littler and littler and littler, they smaller and smaller and smaller. So it's kind of silvery one direction and goldy colored the other direction, because it's gold, platinum, gold, platinum, gold, platinum. Looks like platinum on the outside because that's what it is. But it's also gold too. And so when it recondenses, it self-assembles into this cubic arrangement. What you're seeing there is planes of cleavage, but they followed the magnetic lines within the crystal as it was cooling. These things get really hot, man. The plasma, right? High voltage spark with air being forced through it. And so we have AUPT for you and me with my $135 Cut 50 plasma cutter. I almost had it. It was almost good enough. So next we'll do it with a little less effort and a little more finesse, maybe. Just kind of turn the power on and turn the temperature up, and there you have it. So isn't this fun, huh?